Hey everyone, welcome back. So we now know as what is deep neural network. So a deep neural network will contain majorly four important things. They are input layer, hidden layer, activation and the output layer. The input layer receives the data given from the outside world and the hidden layer gets the data from the input and then process the information, and based on the activation that is present on each neuron, it processes the information and sends the output to the output layer. So this is what we know. But the question is, how does it actually work? That is, how an input that I send to my input layer, how does it get processed inside this deep neural network which you see here? So how does it gets processed inside these layers, and how can I get an output? So since analyzing this whole deep neural network is little confusing for the first time, let's do one thing guys. So let's get a single neuron and let's learn from the single neuron as how it receives the input, how it processes the information and how it produces the output. Once we analyze as how a single neuron works, we'll increase the complexity and understand as how this deep neural network works. Okay, so to begin with, let me consider a single neuron. So let's say I have a neuron which looks like this. So I'll call this as a neuron N. And this single neuron takes two inputs. I'll call them as x1 and x2. When I say it as neuron, what it normally will have is like when it receives the input from the input layer, it will normally perform two important things. They are summation and the second one is activation. And whenever it is performing this summation and activation, so it will also have one more component that is known as bias. Okay. Now, when I say it as summation, what it means is like it is a weighted product of the inputs plus the bias term of that particular neuron. So if I say it as summation, what it means is like, let's say if I have the weights as W1 for X1 and W2 for X2. So the summation part means W1 X1 plus W2 X2 plus B. So here B is nothing but the bias term. And once this summation operation is done, we'll perform the activation on this particular summation. So if I have a activation function as sigmoid, so if I have an activation as sigmoid, so this is nothing but, after performing the activation, it is nothing but sigmoid of sigma. So in other words, if I represent this in the sigmoid equation, this is nothing but 1 over 1 plus e power minus of w1 x1 plus w2 x2 plus b. So this is what will be the output of a single neuron with the activation of sigmoid. So if I want to represent in my original neuron representation, so this will have an output which is nothing but y hat. So here I can now say as y hat is equal to 1 over 1 plus e power minus of w1 x1 plus w2 x2 plus b. Now I'll repeat this again guys. Whenever an input passes through a neuron, two things takes place. First is summation and second one is activation. In my case, I have chosen a neuron with sigmoid activation. So as a first of summation, what it does, it is nothing but the linear operation. So what is linear operation? Linear operation is nothing but weighted product or weighted product of inputs plus the bias term. So that is nothing but w1 x1 plus w2 x2 plus b. And second step is activation. In my case, since I said that this neuron is having the activation function of sigmoid, that means whatever the value that I get as a summation, that summation will be used as 1 over 1 plus e power minus of w1 x1 plus w2 x2 plus b. If I want to represent the sigmoid in an equation, I can say as 1 over 1 plus e power minus z. So here Z is nothing but the value that I get after I perform the linear operation. Got it? Now to give you a better understanding of this, so let's say if I have a input, say x1 as 1 and x2 as 2, and let's say I have the w1 as 10 and w2 as 20, and let's assume the b term as 1, then y hat is nothing but 1 over 1 plus e power minus of w1 x1 plus w2 x2 plus b. In other words, I can write as 1 over 1 plus e power minus of w1 x1. So w1 is 10, x1 is 1, so 10 plus w2 x2, 20 into 2, 40, plus b term is 1. So this is nothing but 1 over 1 plus e power minus 51. So if I compute it, this is the output of my sigmoid neuron. So since I'm using the sigmoid function, that is sigmoid activation, the output will fall between 0 to 1. Now this operation, that is finding the y hat, so that is finding the y hat from a weighted average, and then this activation is known as forward pass. And if I change or if I adjust the parameters of my particular model during the training with the use of gradients, then we'll call them as backward pass. So don't worry about these terms, that is forward pass and backward pass. We'll come back to these concepts again in the future videos. For now, I want you to understand this basic concept. So to summarize of this today's class, I can say as if I consider a single neuron with two inputs, a single neuron or in any neuron, basically two things takes place: summation and activation. When I say it as summation, it is nothing but weighted product of input plus bias term. So when I say it as weights, so each feature of the input that we receive will have each weight, and individual neuron will have a single bias. Okay. And when I say it as summation, so it is nothing but linear operation w1 x1 plus w2 x2 plus b. And when I say it as activation, we will just apply this, or we will just use this linear term and use it in my activation term. In my case, I have the activation as sigmoid. Hence, I have written as 1 over 1 plus e power minus of w1 x1 plus w2 x2 plus b. Now you might ask me, so what happens if I have a ReLU activation function? So if I have a ReLU activation function, so suppose if I call z as w1 x1 plus w2 x2 plus b, then we know that the ReLU means if the value is less than 0. So if the value is 0 or if the value is less than 0, then at that time the output will be 0. If the value is positive, then at that time the value will be positive, right? So I can represent it something like this. It will be 0 if z is lesser than or equal to 0, and the output will be, it would be z if z is greater than 0. So I'll represent this again, ReLU of z. So if we instead of sigmoid, if I have a ReLU activation function, it is nothing but ReLU of z is equal to, it would be 0 if z is less than or equal to 0. It would be z if z is greater than 0. Got it? Don't worry about various activations, but the core thing I want you to remember is this. So when we pass an input through a neuron, two things takes place: linear operation and activation. Okay? Cool. So I'll see you in the next class, guys.